In this video, we're going to be talking about estimating population mean. And usually in all of the textbooks, the first thing that you're estimating population mean, but you know the standard deviation of the population. Now, this is not a very realistic situation. If you know the standard deviation, why don't you know the mean of the population? That's the question. So it doesn't happen very often. So we are going to skip this situation and we're going to go to the scenario where you don't know the standard deviation. But just in general, the general idea is to find the margin of error for the population mean. We're going to use our sample mean as a point estimate, and then we're going to have some margin of error to build the confidence interval. So here's our next more realistic situation that actually we're going to use when the sigma or the standard deviation of the population is unknown. So this is a situation where we don't know the mean and we don't know the standard deviation of the population. So in this case, we're gonna actually use both the mean and the standard deviation of the sample to estimate the standard deviation and the mean of the population. Now that introduces another level of uncertainty. So we're using two parameters that are not exact, like the mean and the standard deviation of a sample. So therefore, we're going to use a t-distribution for the critical values. Now, what are the requirements? We're going to check the requirements all the time. So the requirements are as follows. We can estimate the population mean if our sample is a simple random sample and we don't know the population of standard deviation, and then the conditions for the central limit theorem are satisfied. What are those conditions? The condition is that either the population of the normally distributed, the population that we're taking samples from, is randomly distributed, or we have a sample of 30 or more, or both. Okay, so in order to, again, I'm going to repeat that. In order to be able to use this procedure that we're about to discuss, these requirements have to be met. We have to have a simple random sample when now the sigma is unknown. When sigma known, we're going to use a different procedure, which we're not covering in this section. And your population has to be normally distributed, or the sample size has to be large, or both. And this ensures that our sample means are normally distributed. And we could actually use normal distribution in order to find our population mean. Okay, so for critical values, we're gonna use a t-distribution, not a z-distribution, but a t-distribution with a degree of freedom. And the degree of freedom is gonna be n minus 1. Now, this is how the formula for finding our confidence interval, where x bar is our point estimate, that's our sample mean, and ME is the margin of error, and the margin of error is found using this formula. It's t, our critical value from the t distribution of alpha over 2 multiplied by the standard deviation of the sample divided by the square root of the sample size. Remember, our standard deviation from the central limit theorem of distribution of sample means from the central limit theorem. Now, we had sigma here, but because we don't have sigma, we're using S instead. So let's put to practice what we just discussed. It says, for the next two problems, calculate the margin of error if the necessary requirements are satisfied. If the requirements are not all satisfied, state that the margin of error cannot be calculated by using the methods of this section. So we're looking at the confidence level of 95%. So alpha is 0.05. The sample size is 9, and sigma is not known. So, and okay, it doesn't say it here, but we're gonna assume, okay. That samples are simple random samples. Okay. Simple random samples. Okay, do we have everything else? Sigma is not known. Okay, check. What about the normal distribution of sample means? Well, we either need the parent normal distribution or the large sample. Here, the sample is not large, and we have no idea about the shape of the parent distribution. So cannot do anything here. We're gonna answer cannot be calculated by using the methods of this section. All right, let's proceed to our next question. It says the confidence level is 99%, the sample size is 9, sigma is 15, and the original population is normally distributed. Okay, so we have normal distribution, right? So even though the sample is small, we have a normal distribution. So that ensures that we have a normal distribution of sample means. However, we know sigma here. So this means that we cannot use this specific method. All right, so the margin of error cannot be calculated by using the methods of this section either. All right, next. I promise you we will calculate one soon. Use the given confidence level and sample data to find a confidence interval for estimating the population mean. We have speeds of drivers ticketed in a 55 miles per hour zone. We have a 95% confidence level. So that gives us alpha of 0.05. N equals 90, so large sample, check. Okay, we know the sample mean, and the sigma is known to be 3.4 miles per hour. So since sigma is known, again, we cannot use the methods of this section. There you go. All right, let's take a look at this problem. It says construct the confidence interval for the population mean. Assume that the population has a normal distribution and the sample is a simple random. We're looking at a lifespan of desktop PC with a 99% confidence, n equals 21. Mean of the sample is 6.8 years, and the standard deviation of the sample is 2.4 years. Okay, so are the conditions satisfied? Do we have a simple random sample? Yes. Do we know the standard deviation of the population? No. Do we have a simple distribution of sample means? Yes, because even though our sample is small, it's not greater than 30, it's compensated by the fact that population has a normal distribution. So remember, we have to have one or the other or both. And we do have the normal distribution. All right. So in with these assumptions met or requirements met, we can actually estimate the population mean. So the point estimate is going to be that mean, right? So mean of the population is approximately equals to the sample mean, okay? That's the point estimate. Now, the interval, for the interval estimate, we're going to have interval estimate. That's either mean of the sample minus the margin of error to the mean of the sample plus the margin of error. So we need to calculate that margin of error in order to come up with that interval. Okay, what's the margin of error? Well, the formula for the margin of error is this. We need a t, critical value t, and multiply by s divided by square root of n. Let's figure out the critical value t. If my confidence level is 99%, that means that alpha is 0.01. That means that alpha over 2 is 0.005 and 0.005. Okay, so I need to find the t with 0.005 with the degree of freedom. Remember, t also depends on degree of freedom. So degree of freedom here is n minus 1, which is going to be 20. So what we're going to do, we're going to go to our StuckCrunch. And this time I'm going to open the t distribution calculators, t, and put in the degree of freedom and the area. If we look into the left, then I'm going to put 0.005, but if I switch it to the right, it's going to be 0.995. Oh, I'm sorry. Well, that's going to give me the left one. I want the one on the right. So 0.005. And that t value is 2.845. You can round that value to 3 decimal places usually. Okay, so now I have my t value from the formula. let me finish. Let's finish the problem. So the t-value is 2.845. Now I need to multiply it by s divided by the square root of n. All right. And when I put it into my calculator, I get approximately 1.49. 1.49. That's my margin of error. So my interval estimate is going to be either mu is 6.8 plus or minus 1.49. Or if I want to write it in this form, that's going to be 6.8 minus 1.49 to 6.8 plus 1.49. Which will give me 5.34 to 8.29. So we have, we're going to have three different ways of writing our interval. We can write it in this way. We can write it in this way. Or we could just write it using interval notation, just writing interval from 5.34, comma, 8.29. So our, what are we gonna write? How do we interpret this confidence interval? We're gonna write that we are 99% confident that our population mean is in the interval between 5.34 and 8.29 years. So here we are. We are 99% confident that the true lifespan of all desktop PCs is between 5.34 and 8.29 years. That's how we interpret our confidence interval.